Actually, control chart is a chart to study the variation in the production and service processes. Basically, the common causes of variation, and they are assignable cause of variation. So, when in the production of the real, in the real market, actually, how they do defects, how they do, how the management determines the product is, this product is within the specification, and some products is over the specification. So one of the tool they use for the to investigate the source of variation is control chart. Okay, and here I will introduce few different types of control chart. Okay, this is just an introduction on the variation. Okay, class, what is the meaning of variation? When we talk about variation means something differ. Okay, something a different. Okay, what are the different thing? That is variation. So the common causes of variation, actually, it's very difficult to identify, and we can't avoid that. For example, diameter, weight, service time, temperature, and apart from that, assignable causes of variation. Okay, causes. Okay, assignable causes, the causes that can be identified and eliminated. Okay, so for example, employee training, machine need any repair or something like that. Okay, we do have few people now. Okay, so now, so these are the measuring of variation class, the standard deviation. So when we talk about standard deviation, okay, this curve is actually represent a very small standard deviation, while this curve represent large standard deviation. Okay, now, a process capability. So a measure of the ability of a process to meet the present design specification. For example, class, we must determine whether the process can do what we are asking it to do. Okay, and the tolerance limit, whether it's plus minus 3 or plus minus 6. Okay, for example, okay, here the relationship between process variability and specification width. So class, here this is the lower limit, this is upper limit. Okay, so the process variability, this is plus minus 3. Okay, it depends on the management. Okay, some prefer plus minus 3, some go for plus minus 6 as well, some might go for plus minus 1. It's depend, but usually the standard one is plus minus 3. So something is within this limit is considered, acceptable. Okay, the variation are acceptable. Below the lower limit and higher the upper limit is considered some bias. Okay, some error is already introduced. So probably the management have to introduce, okay, what are the costs for the error. Okay, this is the structure. I mean, a figure B shows the process variability outside specification width. Okay, this is outside specification width. Okay, process variability, and this is the process variability inside. Okay, specification width. Okay, so now class, 3 sigma capability, that means plus minus the mean output is plus minus standard deviation falls within a design specification. Okay, so for example, a 3 sigma capable process, it can be produced 2600 defects for every million units produced. So there are 6 sigma capability as well. Okay, so the six sigma capability means smaller variation and therefore higher quality. So class, as I mean, when we compare with plus minus 3 and plus minus 6, actually plus minus 6 is even more smaller, so the quality will be better compared to plus minus 3. So class, here let me introduce about control chart. Okay, control chart is basically a statistical quality control tool used in the monitoring variation. Okay, in the characteristic of a product or services. Okay, they use control chart to monitor the performance, or they do investigate got any variation between the batches. Okay, um of their production, whether it's meet their specification or not. Okay, so now the use of control chart is focuses on the time dimension and the nature of the variability in the system. So control chart may also use to study the past performance and to evaluate the present conditions as well. So data that collected from a control chart may form the basis for improvement. So basically, class, whatever data that we are getting from control chart, okay, they will use that for the improvement purpose. Okay, so now, so class, this is basically a control chart. Okay, this is upper control limit. Okay, UCL stands for upper control limit, and LCL stands for lower control limit. Okay, these are these specification that plus minus 3. So within this plus minus 3, if our data, okay, around this is considered, it's okay, it's within the acceptable range. Okay, if let's say if the data is like falls under upper control limit or lower control limit, that means there is some bias there. Okay, and for example, class, this is the graph of sample data plotted over time. Okay, so we can clearly observe here. Okay, these are the assignable causes of variation, and these are the random variation. So class, you can observe this control chart, all the data. Okay, as time increase, the data is within the specific process average, which is plus minus 3. But there is one assignable cause of variation, okay, which is at time at fifth minute. Okay, so probably they have to investigate why. Okay, it's over the it's higher the upper control limit. Probably, what are the problem with this. Okay, so here we have three types of pattern, three patterns of control charts. For example, this is the common causes where no points outside control limit. Okay, this is very common causes. And special causes, class, 2 points outside control limit. These are considered, 1 and 2 outside the control limit. And downward pattern, that means no points are outside the control limit, however 8 or more points are in trend. Okay, it's like in trend. So this is a downward pattern. Okay, now control chart basically shows sample data plotted on a graph with the center line. So class, CL stands for central line, UCL stands for upper control limit, LCL stands for lower control limit. Okay, and again, class, observation out of control, and this is the observation of out of control. So class, these are the plus minus 3, and this is considered plus minus okay, 6. Okay, just one moment, class, I think we have someone just came in to join. Okay, so far we have 34 participants. Okay, so class, there are different types of control chart. Basically, control chart that used for variables are used to monitor characteristics that can be measured. Example, length, weight, diameter, time. So we will use as mean X bar charts and R range X R chart. That means, class, X bar charts stands for mean chart, and range R chart stands for range. So these are the control chart for variables. Okay, and data control chart for attributes. Okay, are used to monitor characteristics that have discrete values and can be counted. For example, number of broken eggs in a box. Okay, so for that we'll use P chart and C chart. Okay, so the formulas is also different. Okay, we still have people coming in. Okay, we already have 34 now. Okay, so type of control chart is done. Okay, now, so class, let's move on to the let's move on to the X bar chart and R chart. So control chart for variables, okay, as I mentioned before, okay, mean X bar charts, okay, they are, I mean, it's used the data of average value observed over the time, while R chart use the distribution over the time, okay. So for example, okay, these are the X bar and R chart monitor different parameters. For example, these are the shift in detected by X chart but not R chart. So this is X chart, and this is R chart. So class, basically R chart they use range, okay, and range means higher value minus lower value. Mean, we will plus everything and divide by how many numbers, so that is mean. So if we observe here, shift in mean detected by X chart but not R chart. So that means shift in mean can be only detected by X chart but not R chart. But if we want to detect the dispersion, okay, it can be done by the R chart but not by X chart. Okay, so not, this is the dispersion chart and this is the X chart. So class, now this is the example of the question, okay, how to plot X bar chart. Okay, for example, a quality control inspector at the Coca-Cola free soft drink company has taken three samples with four observation. Class, three samples with four observation, each of the volume of the bottles filled. If the standard deviation of the bottle operation is zero point 0.2 ounce, use the data to develop the control chart with limits of 3 standard deviation, okay, for 16-ounce bottle operation. Okay, now class, we have a table here, okay, and we have four observation and the time, okay, three times it was taken. Okay, now, so first of all, okay, remember class, whenever we talk about X bar chart, we are referring to the mean. Okay, so now the first thing we have to do is we have to calculate the mean. Okay, mean of the four observation. Okay, you have to calculate the mean, class, plus divide by 4. I think everyone here should know how to calculate mean. Okay, so this is the formula, okay, to calculate the standard deviation of the sample mean. That means class, this is standard deviation, it's given in the question, which is 0.2 divide by 4, n equals to 4. It's a 4 observation, so it's 4, which is 0.1. So the standard deviation for the sample mean is 0.1. So class, okay, this is how we will calculate the central line, upper control limit and lower control limit. Okay, central line, we have to plus all these three, one, two, three, okay, sample means, and divide by 3. That will be the central line. While control limit, okay, upper control limit is mean plus plus just one moment class, I think we still have people coming in. Okay, sorry, 35 now. Okay, so so to calculate the upper control limit and lower control limit, this is mean plus Z standard deviation. So class, the standard deviation 0.1. Okay, this is the value 0.1. Okay, this 3 is actually the sigma, I mean plus minus 3 standard deviation. So this is the limits, plus minus 3. And so this is your upper control limit, lower control limit. Class, the formula, this is the formula for X bar chart. Okay, again, I'm repeating, this is only for X bar chart. Okay, so this is your lower control limit, your central line and upper control limit. Okay, and this data is, I should provide you this data in order for you to plot, but here I'm just teaching you guys, okay, how to calculate the central line and control limits, okay, for Z value for 3. Okay, class, so far so good or not about control chart? Hello, anyone please respond?
Yes, doctor.
Yes,
Okay,
doctor.
good. Okay, good. Okay, class. Okay, class. Again, there is another one method to calculate X bar chart. Okay. Without, because some, in this case, all the information is very clear and it's very simple. Okay, but there will be some other cases. For example, in this case, okay, we can use an alternative method for X bar chart using R chart and A2 factor. Okay, this is consider A2 factor, but this data will be given. Okay, if let's say this question, okay, if let's say I want to test this kind of question in your exam, okay, this data will be given. Okay, by using this method, the sigma for the process distribution is not known. So if let's say class, the sigma for the process distribution is not known, probably when you ask to plot X bar chart and the sigma for the distribution is not given, okay, you may use this method. Okay, here, calculate the range of each sample and average range. So for example, class, the same question here, okay, but we are calculating the sample range. That means lowest value minus highest value. Okay, sorry, highest value 16 minus lowest value, which is 0.2. So we just find the range, okay, between highest and lowest each, and find the mean of the range. Okay, now once we find the mean of the range, so here we will find the central line. Okay, again class, the central line is follow the previous table. This is the central line value. The central line 15.92, 15.92. Okay, the control limits will be a bit different. For example, previously, if let's say the sigma value given means, we will use this formula. It's very simple. Okay, if let's say sigma value is not given and you are asked to draw X bar chart, then you have to use this alternative method. Okay, so in this case, you have to use mean plus A2R. So class, here, your R value you will get from here. Okay, your A2 value, you have to use this table. Okay, let's move on. Let's go through this table class. So here they choose 0.73. Okay, so the sample is n, A2 factor is 0.73. Okay, sample is 4. So why sample is 4? So they do the observation. They took this observation. So sample size is 4. So sample size is 4. A2 factor is 0.73. So the 0.73. So now you will get the upper control limit and lower control limit. So here class, the summary of the calculation is here. Central line, sorry, the summary of the calculation is here. So central line, upper control limit and lower control limit. This is the alternative method to find x to calculate the central line, upper control limit, lower control limit for X bar chart. If let's say the limit is not given. Okay, so class, now, so X bar chart we are done. Okay, let's move on to the control chart for R. Okay, for R chart, basically the formula for R chart is central line. Okay, the so class, for the, and it's a mean of the R. So again, this is the mean of the R, which is 0.233. So this is the central line for R chart, and upper control limit and lower control limit is D4R, D3R. So D4R, again class, the R value is 0.233, 0.233. Okay, fine. But your D4, so your D4 value for n equals to 4. N equals to 4, your D4 value is 2.28, and your D3 value is 0. So it's 0. So your lower control limit starts from 0 and your upper control limit is 0.53. Okay, so class, any questions so far? Hello, any questions so far?
No, doctor.
Okay, thank you. So this is the example of R bar control chart. Okay, so class, here got any variation, I mean anything that any outliers are not class in this part. Okay, we don't observe any outliers. Okay, all the values are within the specification. Okay, that means this process is considered okay. Okay, can be acceptable. Okay, now we are done with X and R chart. Okay, now let's move on to the attributes control chart. Okay, there is another one control chart. Okay, which is attribute control chart, which is C chart and P chart. C chart is for counts, P chart is for the proportions. So now attributes control chart will use when the sample size are not constant and are unknown. Okay, unknown, use counts chart. Okay, for example, C chart. Okay, now here, these are the C chart for the number of defects. Okay, example class. Okay, attributes control chart. When the sample size are constant and are known, use proportion charts. So that is considered P charts. Okay, now let's move on to the calculation for P chart and C chart. So, class, you should know when you should use P chart and when you should use C chart. So, previously, don't get confused, class. X chart, R chart is different. Now, we have moved into P chart and C chart. So, class, when we are talking about P chart, it's for the quality characteristics that are districts and involve yes, no, or good, bad decision. For example, percentage of broken eggs, okay, in a carton, percentage of leaking tubes in a box or something like that. While C chart for the district defects, okay, when there can be more than one defects per unit. For example, number of complaints per customers at hotel, okay, something like that. Okay, now let's plot P chart. Okay, this is the example of a question for P chart. So here, class, a production manager for a tire company has inspected the number of defective tires in 5 random samples with 20 tires in each samples. So the table below shows the number of defective tires in each samples of 20 tires. So here, class, so we have sample size is 20, number of defective is okay. Each sample we have some defects. Okay. So now, so how to calculate the percentage of defective of each samples and overall percentage of defective percentage of defective, which is P chart. Okay, now we are plotting the P chart class. Okay, here number of defective. So sample size is here. So percentage of defective. Okay, this is 0.15. So class, total actually this is actually 9 over 100. So we have to divide and class. Okay, this is actually overall is 9 over 100. So this one is 3 over 20. Okay, each sample we have to divide by the sample size. For example, 3 over 20 is 0.15. 2 over 20 is okay, 2 divided by 20 will be 0.1. Okay, so something okay, like that class. So now this is the formula to find the standard deviation for P. Okay, this is P prime over 1 minus P prime over N. So our sample size is very clear. Is in the question about 20. So your N will be 20. Okay, now your P is actually 0.09. Okay, when your P is 0.09, automatically when 1 minus P will be 0.91. So class, this is how we will calculate the standard deviation for P chart. Now, the central line. Central line is actually it's a mean of the P. So mean of the P is the okay. This is the mean class. This is mean. Okay, it's not total when calculated. It's actually a mean. So it's a mean of P which is 0.09. This is 0.09 and upper control limit and lower control limit. Okay, mean of P plus Z standard deviation. So the Z is given if let's say sometimes class they it's okay for you to I mean, some most of the cases they will mention the limits. Okay, so in this question they didn't mention, but usually in your exam questions we will be clearly mention, okay, your limit. So here when you calculate the upper control limit, lower control limit, the limit is actually 3. Okay, so 0.064 is here. Okay, your standard deviation. Okay, so now your upper control limit and lower control limit value is ready. Okay, here there is one thing, class, you have to focus, which is your lower control limit value, which is negative. So whenever your value becomes negative, automatically you will have to put 0. That means, class, we can't go up to negative. Okay, so the lowest is 0. So that's why when you get your lower control limit negative, so the you automatically you just have to put 0, because we can't plot something in the negative, okay, in the control chart. So we have to plot as the 0. I mean, we have to just write as 0. Okay. Now, so this is how it will be. Okay. So your lower control limit will be on 0. Okay. So I hope the explanation is clear. So now, class, let's move on to the C chart. Okay. So the number of weekly customer complaints are monitored in a large hotel. So develop a 3 sigma control limits for a C chart using the data table on your right. Okay, this is the table. So class, we have 10 weeks and the number of complaints that we receive is 22. So now the central line, which is C bar, so the number of complaints, again, number of samples. So number of samples actually 10 and complaints is 22. So this is how we will calculate the central line. While upper control limit, lower control limit for plus minus 3, again here. C prime, so, sorry, this is C mean, your this one 2.2 plus, again, okay, this is your standard deviation, I mean, standard deviation of, sorry, square root of 2.2. So again here, class, your lower control limit is negative, so automatically the answer will be 0. Okay, so now service. So the control chart basically, okay, in the service organization, okay, have lag behind the manufacturers in the use of statistical quality tool. So basically the statistical measurements are required and it is more difficult to measure the quality of a service. So the service produced must be more intangible products. Okay, perceptions of the quality are highly subjective. So a way to deal with the service quality is to devise the uh, proper or quantifiable measurements of the service element. So these are the example, like check-in time, number of complaints, number of telephone rings before the call is answered. Acceptable control limits can be developed and charted. Okay, this is how this, they use the control chart. Okay, class. Here I have given a clear example, okay, of the coffee production, the coffee strain, class. Okay, for example, imagine that coffee strain was being evaluated on a scale of 1 to 10 each time a new pot was made. So the results were plotted on a control chart like this. So class, here, so the yellow color line, probably it can be plus minus 3. Okay, sorry, this is, actually the tolerance limit is higher, but if you observe the tolerance limit is very low, very small. Okay, so the horizontal lines represent the mean average of the recent coffee strain numbers, and the upper and lower lines represent the upper and lower control limits. So class, if the coffee making process is stable and only affected by the common causes of variation, if let's say it's only affected by the common causes of variation, usually all the coffee strands value should land inside the two control limits. So class, actually it's just lies within the two control limit, okay, scattered randomly above and below the average value. If let's say if let's say the coffee strand will fall below the lower control limit or above the control limit, or if the coffee strand were trending upwards or downwards, it could be due to the special cause. Okay, so here just now I have mentioned about the common causes, and if let's say if we observe all this kind of pattern, that means it's because of these special causes. Therefore, a process adjustment or the corrective action should be called for. Okay, the management. Okay, this is how class they use the control chart in the industry to monitor their production. So class, with that, okay, I have done my lecture. Okay, so any questions so far, class, on control chart?
No question, doctor.
No question. Okay, class. Okay, if you have any question, you can always email me, no problem. And class, again, I have to remind everyone here, please log in your attendance. One. Second, kindly download your assignments on control chart, and you have to submit the assignment before 1st of June. And third, okay, today we are having quiz. Okay, and the quiz time is given only today until before 12. Okay, 12 a.m. today. Please log in and complete your quiz today. Okay, so class, with that, thank you so much for your cooperation. Most probably next week, Monday will be public holiday, so no class, and I will meet you guys on the following week with the new chapter. Okay, we still have proficiency testing to cover and certified reference material to cover. Okay, so any questions so far, class? Is all the instruction is clear?
Doctor,
Yes.
may I know the quiz later? It's multiple attempts or what? Is there a time limit?
Yeah, it's no, I didn't set any time limit, but you can try. No, it's not a multiple. It's one time you have to try. So, I mean, yeah, it's a MCQ based questions lah.
All right, thank you.
Okay, welcome. Let me answer some questions. Oh, no questions. Okay, so class, since there is no question, but let me check the time limit again. Okay, I will check on that. Okay, so thank you so much, class.
Thank you, doctor.
Doctor.
Yeah. Hello. Anything, class?